Hello everyone, welcome back. So in this lecture, we are going to discuss few of the fundamental terms which we are going to use very frequently in automata theory. So these are the terms which we are going to discuss. In this lecture, we are going to talk about the alphabet, strings, few of the operations on strings like how to calculate the length of a string, how to find out the substring of a string, how to find out prefix of a string, suffix of a string, then how to find out power of an alphabet, then clean closure or clean star closure, positive closure, what is a language, how to define it, and what is a grammar. Okay, so let's begin the discussion. The very first thing is alphabet. It is very well known term in automata theory or theory of computation. An alphabet is a set of finite non-empty set of symbols. Non-empty set of symbols, those are finite in nature, right? So if I consider, let's say, English language, there are 26 alphabet. Okay, so the set of all character like A to Z, we can say it is the alphabet, set of alphabet for English language, right? So similarly, we can take a number of examples. Generally, we represent with a summation symbol. So A comma B is an alphabet of two symbols where there are two symbols A and B only. This is another example of set of alphabet over 0 and 1. It is a binary kind of alphabet. And there is another alphabet which we use in decimal system. So we use 0 to 9 symbols in decimal system. So there is another example we can take, set of alphabet or alphabet. There is possibly other alphabet in natural languages like Latin alphabet. It is having Latin symbols. Devanagari alphabet for like Sanskrit or Hindi, we use Devanagari alphabets, and for Chinese we use Chinese alphabet. Okay, so with these example, I think you can get a clear idea what is an alphabet. Then the next thing is the string. So the combination of alphabet or collection of alphabet, sequential order of the alphabet, we consider it is a string. So a string is any sequence of zero or more symbols, right? So please do remember. So when I'm saying zero or more symbol, that means there is a notion of empty string. If there is no symbol is coming, then also a string can be defined like empty string. Okay, so over a given alphabet, so any alphabet, like you can take one string AAB, which is defined over alphabet A comma B. Okay, so there are only two symbols, and any string I can take. Let's say I have taken AAB here. So if we want to define empty string, generally empty string is depicted or represented with epsilon symbol. So empty string is a string with zero number of symbols. Zero number of symbols, no symbol will occur. Okay, in the sequence. Empty string is also called null string. Okay. So an empty string is a string with zero symbols or letters in a sequence. It's like having an empty sentence, no sentence. Let's say I'm not saying something for a little duration or long duration of time. You consider, okay, nothing has been said by me or some other person. That is empty sentence. Okay, or like a blank piece of paper. Now the next, operations on a string. So there are few operations we can perform on these strings, like we can find out the length of a string. So the length of a string is nothing but the count of the character present in that particular string, or count of the symbol, right? So if we take the example of AAB, so if we try to find out the length of AAB, because there are three symbols, the length will be concluded as 3. Okay, if we try to find out the length of empty string, epsilon is the empty string, the length will be 0, right? If we try to find out the length of AB, because there are two symbols involved in this string, the length will be 2. Similarly, if we try to find out the length of A, there is only one symbol, so the length will be 1. Now the next thing is we can find out the substring of a given string. So what is a substring? A sequence of symbols from any part of the given string over an alphabet, from any part, like from anywhere you pick up one portion and you consider this is the substring. Okay, so every string will have two substrings. One is null and another is the string itself. So these two, any string, let's say if I take ABC, so ABC will also have a substring as null, and ABC will itself will be considered as a substring of ABC, right? So these two will be there in case whatever the example you take up. But if I am taking, let's say, AAB, in case of AAB string, the substring we can define like, so if the string is AAB, you can take one length, so A can be the substring. So initially if you consider 0 length empty string, or epsilon is one of the substring, then A can be one of the substring. Again A is repeated, so A can be the another substring. So one length substring, if you find out AAB, these are the one length string. A is repetitive, so you just consider one length, there are two strings, right, like AB. And if you try to find out the two length string, then you can say AA or AB. So AA and AB will be the two length, and three length because the string itself is the three length, so it is AAB. So these are the substring. Now there's another term called proper substring. So what is a proper substring? Is a substring and its length is less than the given string. So if the string is given AAB, the length of this string is 3, then all the strings those are having less length than 3, so either 2 or 1 or 0 will be considered as the proper substring. So in that case, epsilon, A, B, AA, AB are the proper substring. So here these you can consider as the proper substring. Okay. Right. So accepting this particular string, rest will be considered as proper substring. Then the prefix of a string. So if you consider an example, AAB is given as an string, and the prefix is a substring with the sequence of beginning symbol of a given string. So prefix itself is a kind of substring of a given string, but the substring need to be started with the very first symbol of the string. So the very first symbol of this string is this A. So we can find out the prefix. So one prefix like 0 length, or you can say empty string. So let's say you are having a string S1. If you concatenate S1 with empty string, you will get S1 only, right? So you consider epsilon is the prefix of every string. Okay. So epsilon is one of the 0 length prefix which is applicable for every possible string. Then one length, so one length you need to start with A, so one length you will get A only because you are starting. Then two length you will get AA, then three length you will get AAB, because there is a restriction, you have to start with the very first letter of the string. Okay, so there will be one length prefix, two length prefix, and three length prefix. Proper prefix will not contain this thing, rest of these three prefix will be considered as proper prefix. Okay, so these are the proper prefix, right? Then suffix is also a similar kind of thing. In suffix we consider or start taking the substring from the end symbol. Okay, so if we consider the same string that was AAB, so if the string is given AAB, so the very first suffix you can say the empty string, that is epsilon, because if a string W is given and you concatenate with epsilon, you will get W only, right? So every string can be ended with epsilon, you can assume that. So epsilon is the suffix as well as the prefix of every possible string, right? if you want to find out the one length, then B will be, because we have to start the suffix from the end of the string symbol, so that is B. So B is one length. Then you can consider AB, because B has to be there, so AB is the two length, and then A and B three length suffix of the given string. Now proper suffix will not contain this string, so rest of the strings will be the part of proper suffix of a given string. Okay. Now next is power of an alphabet. So any alphabet is given, like you consider an alphabet or binary alphabet 0 1, or you can consider A comma B. So if this alphabet is given, and if we try to find out the power, so if an alphabet is given like this, if I consider, let's say 0 comma 1, and if we calculate the power of this, so power of this means I am taking power 0, that means 0 length string by utilizing these two symbols. So 0 length string, obviously it will be epsilon. Okay, so that means it will be the set of only empty string. If I consider power of 1, that means one length string. So if the alphabet is 0 1, then the one length string possibly will be 2. And if I write power of alphabet like 2, then two length string I am actually talking about. So 0 0, 0 1, 1 0, 1 1 kind of two length strings are possible, and so on. So if we consider over alphabet A comma B 3 length, then the 3 length there will be 8 strings, 1 2 3 4 5 6 7 8, because there are 3 length string, and the set of alphabet is having only 2 symbols. So 2 to the power 3, that means 8. Okay, so that is the notion of power of alphabet. Then clean star closure. So any alphabet is given which is represented by summation like this. If I put this star as a power here, that means I'm trying to write like this. It is the union of 0 length string, all possible 0 length, that means epsilon, then 1 length, then 2 length, then 3 length, then 4 length, and so on till infinite length. So every possible string which can be generated over an alphabet, let's say epsilon, or this summation, which is written as clean star closure. Okay, it is a unary operator, right? Because it requires only one operand. Then the next closure is positive closure. Positive closure does not contain empty string. Clean star closure contain empty string. Okay, so we can write this positive closure is the clean closure minus empty string. Okay, so from the clean star closure, if we do not consider the empty string, it will become the positive closure. Okay, so positive closure, let's say if I take the example, let's say there is an alphabet I'm taking as 0 comma 1, let's say, and if I write positive closure of this, that means I'm trying to say one length string, that is 0 1, union of 1 length, 2 length, 3 length, 4 length till infinite, but not 0 length string. Okay, so 2 length will be 0 0, 0 1, 1 0, 1 1, then 3 length, so there will be 0 0 0, then 0 0 1, then 0 1 0, then 0 1 1, and so on. So 1 0 0, 1 0 1, 1 1 0, 1 1 1, right? And then 4 length, and so on. So this is the meaning of positive closure. Okay, then the next is language. So what is a language? A language is a collection of or set of strings formed using a specific set of symbols or letters known as alphabet. So every language will be defined over a set of symbols, like English language having English alphabet, those are 26 in number. Chinese language will have its own alphabet. Hindi or Sanskrit is having its own alphabet, set of alphabet. So what is a language? It is a collection of string, and those strings will be defined over the given alphabet, okay, or set of symbols, right? So if you take an example, let's say one alphabet is given like this, there are only two symbols A, B here. Using this alphabet, we can create different strings. So for the sake of easiness, if you consider like AB, comma AAB, if this is the only set, then this set will be considered as a language, which is defined over the alphabet A, comma B. Okay. So in this case, the language consists of two strings AB and AAB. These strings are formed using the symbol from the given alphabet AB. So we can say that AB, comma AAB is a language over this particular given alphabet, right? Now there are different types of languages. So finite languages and infinite languages. Okay. So what is a finite language? As the term suggests, finite language will have finite number of strings. So finite language is a set of finite number of strings. Okay. And infinite language will contain infinite number of strings. So for an example, let's say if I take a language which is having only three strings like cat, dog and bird. So if there are only limited number of strings in the set of language, then that language we can define as the finite language. But infinite language, let's say if we consider English language, because English is an evolving kind of language, so we cannot say the vocabulary of English is now fixed. Later on we can introduce a few new terms or new words or new strings in the English. So English we can treat as infinite kind of language, right? Then the grammar. So grammar has a set of rules, and this set of rules helps us to generate sentences. So if I take the example of, let's say, English, in English, if I consider a sentence actually it is nothing but sequence of some strings, and those strings are legal strings which we consider as words. Those are available in vocabulary of the language. So if I consider, let's say, English, in English, if I'm saying, let's say, Mohan is a legal word, it is the name of some person, is a legal word or legal string in English. If I'm saying going is a legal word in English, to is a legal word, and let's say school. So this is a sentence, right? This sentence, when we try to combine the given vocabulary strings or legal words in a language, there has to be some rule. Because if I write, it is like to is going Mohan school. Although all the words are same, but this sentence is not legal. It is not correct sentence. So how to decide whether the generated string is legal as per the restriction of the language or not? That will be decided by the grammar of the language. Okay. So a grammar can be defined in formal languages. A grammar can be defined by defining these four tuples. So these four tuples are, the very first tuple is the set of non-terminals, then set of terminals, then set of production rules, and S is the starting symbol of the grammar. Okay. So in a rule, you will often find out the rule generally we write like X derives Y kind of thing. X derives X implies Y. So generally we write rule in this manner. Okay. There are different types of grammars we will discuss in coming lectures. So I hope this lecture will help you to understand all these important terms. Okay. So we will further continue the discussion in the next lecture. Thank you for connecting. See you in the next class.